Well, welcome to notes number 5. These are density notes. We're going to be talking about density in these notes. They are on the shorter side as well, just like the matter notes. So you'll like these notes as well. There's only 3 questions, and this concept of density is something that you should have come across before in probably 8th grade science. So let's go ahead and get started. Okay, so again, notes number 5, density notes. Our first question is, what is density? So density is a physical property of matter. Okay, so remember in the last notes we were talking about physical versus chemical properties of matter. Well, density is a physical property of matter, since measuring density does not change the chemical composition of whatever substance you are measuring the density of. Okay. Now, in particular, though, it's a specific kind of physical property called an intrinsic or intensive property. Okay, what this means is that it doesn't depend on the size or the shape of the substance. Okay, so if you had 100 grams of gold, okay, and you measured the density of the gold, okay, it would be the exact same density as if you only had 1 gram of gold. Okay, so it doesn't depend on the size or the shape. You can have a lot, you can have a little, you can have it in, a big sculpture form, or you can have it in a blob. Okay, the density of that material, if it's made out of the same substance, is going to have the same exact density. Okay, so in our notes we're going to put down again that it stays constant, and because it stays constant, and it doesn't depend on size or shape, it can be used to identify substances. The density for each particular substance is different. Okay, so that's why we can use it to identify substances. The density for gold is different than the density of water, which is different than the density of carbon dioxide, different than the density of the silver. Okay, so every single substance on Earth has a different density, okay? Some might be very similar or close, but they will have different densities, so that if you had an unknown substance, you could figure out what that substance is by measuring its density, okay? So now let's talk about what density actually is, okay? So density is mass per unit volume. Okay, so what that means is that when you're finding density, you're going to figure out the mass of a substance, so you'll weigh it on a scale, and then you'll also figure out the volume of a substance, either by using graduated cylinder or measuring, length times width times height, and you're going to divide those two numbers to get the density. So you can remember this as the formula density equals mass divided by volume, or if you're more kind of a visual learner, and you may have actually seen this depending on who your 8th grade teacher was, there's something called a density triangle, and let me show you what that is. Okay, so here's what the density triangle looks like. We have a triangle that's kind of set up or divided up into 3 spots. We have mass on top with the little m. We have and D, which means density, and V is volume. Okay, so what this means is that it's kind of a visual to figure out, okay, what do I do when I need to find the density? So whatever you need to find, you cover that one up, and the other 2 kind of show you what that is. So for example, if I cover up the D for density, what I'm left with is mass over volume. Okay, so there you go, mass divided by volume. Okay. Now, what if I wanted to, if I was given density and volume, how do I figure out mass? Well, let's cover up the M. So here, if I cover up the M, I'm left with D and V on the bottom. They're on the same level, so that means that we multiply them. Okay, so if we are given density and volume and we need to find the mass, then we do density times volume. Okay, now let's take a look at the last scenario. What if we're giving density and mass? How do we find volume? Well, if we cover up the V in this triangle, we're left with mass over density, okay, which is mass divided by density, which is going to give us the volume. All right, so it's kind of a simple visual way to kind of work through the density equation, because not all the time are you going to be given mass and volume, you just have to divide. Okay, other times you'll be given volume and density, or mass and density, and you'll have to do some other math there. Okay. Now, the last thing we want to say in this question is we're just going to want to give the units for density. Okay, so if we're taking mass and we're dividing by a volume, all right, our density is going to be a derived unit, okay, meaning that's going to have more than one little letter symbol. And for density, it's either grams per milliliter or grams per liter. Okay, so here we see our grams per milliliter. Remember, mass is always measured in grams, and when we're measuring volume, usually in chemistry, since we're working with mostly liquids in this a substance or dissolved state, we're going to have either milliliters, okay, or if it's a large quantity, liters. Okay, so we've got grams per milliliter or grams per liter. That's going to be our unit for density. So remember, you always want to plug in your unit with your number. So if you're solving a density problem with your number, got to have the units, either grams per milliliter or grams per liter. And again, it's a derived unit, okay, which means that it's more than one type of measurement being made. We're dividing or multiplying numbers to get this special unit. All right, let's take a look at our second question. Our second question is, what is mass? Fairly simple question. You should probably all know what mass is. It's what we measure when we're measuring substances or objects on a scale or balance. Okay, so mass is the amount of a substance. All right, so when you're measuring on a scale, you're measuring how much of a substance you have, and that is its mass. When we're measuring mass, we measure it in the unit grams. All right, if it's a huge mass, we can convert it to kilograms. If it's a really, really, really tiny mass, we can go even smaller, like milligrams and picograms and stuff like that. But the main unit we'll be using is grams. Now, mass is kind of a special little unit here. It does not change with location. All right, so mass and weight are slightly different, and let's take a look at that difference. So mass does not change with location. It's different than weight. The weight of something actually factors in the pull of gravity, which can change with location. And the best example for that is that if you went to the moon, okay? So first off, if you measure your mass or your weight, okay, on Earth, for example, perhaps you weighed 120 pounds here on Earth, and you went to the moon, okay? On the moon, you would weigh 20 pounds, okay, because the pull of gravity is 1/6 of that on the Earth, okay? So on the moon, you would weigh 20 pounds, all right? But you would have the same mass. You're not shrinking as you go down up to the moon, okay? So that's how it's kind of different. Mass does not change. You will have the same mass, the same amount of you, whether you're here on Earth or on the moon, okay? However, your weight will be different because of the pull of gravity, okay? So here on Earth, we usually, we can interchange mass and weight, okay, being kind of the same thing, because the pull of gravity doesn't change a whole lot here on the Earth. So that when you jump on the scale and people are like, "Whoa, how much do you weigh?" They don't ask you, "Well, how much is your mass?" Okay, because we can talk about those things interchangeably here on Earth, but you have to be careful about mass versus weight when you're going to extremely different parts of the universe. Okay, all right. So let's do our last question here, and we're going to talk about volume, because we're going to talk about the two parts of density, I should say, mass, which is what we just covered, and now we're going to talk about volume, which is our other part of this derived unit. Okay, so let's take a look. All right, so our last question is, how do we measure volume? And we're going to start off this discussion with the definition of volume. Okay, so volume is the amount of space that matter takes up. Okay, so mass was how much there is, and volume is how much space that takes up. Okay, so we're going to be talking about how we measure volume of 3 different types of substances. First, we're going to talk about what's called regular objects. Okay, so let's take a look. Regular objects are things like a cube, so like a box, or a cone or a sphere, something that you can mathematically take a measure of and then mathematically figure out. Okay, so for example, if we have the cube, like sugar cube, ice cube, or something like that, we can measure the length and width and the height using a ruler, and then we can multiply those together to get the volume. So that's how you would do it if you had regular kind of objects. Okay, so again, if you had a cube, you measure the length times the width times the height with a ruler. You multiply them all together and you get the volume of that object. Now the unit is going to be in centimeters cubed, okay? Because again, we've got 3 dimensions here, length, width, and height, so we need that cube there, that 3 there, to show that it's more than 1 dimension. All right, so that's how you would find the volume of a regular object. Now we're going to take a look at irregular objects like liquids or powders or something that's not a measurable shape. Okay, so for irregular objects like liquids or powders, you're going to measure in a graduated cylinder. Okay, so this is stuff that the objects that can take the form of the cylinder or the container they're in. We're going to measure in graduated cylinder, and when we do that, usually our unit is going to be the milliliter. Okay, so we're going to have a milliliter for units. Okay, so the last part is talking about how to take a measurement of an irregular solid object, like a big irregular object like a rock that might not be smooth all the way around, or a nice cube, or things like a ring or a crown or a camera, stuff that's not an easy object to measure. Okay, so let's take a look at that one. Okay, so for irregular solid objects, we're going to measure via what's called water displacement. Okay, so what this means is that we are going to fill up a graduated cylinder, not all the way, but part way with water. Then you add your object into it, okay? Figure out the difference in volume between, the water line without the object, the water line with the object, and then you subtract the two in order to get the actual volume of the solid object. So let me write that down and kind of give you a visual. Okay, so if you see here, we've got a little scenario here with our graduated cylinders, and we start with, okay, here's our number 1. We start with just a graduated cylinder filled up part way with water. So in this case, we have 5 milliliters of water. Then we're going to go to step number 2, where we drop our object. In this case, it's a little green rock of a substance into our, or we carefully place, I should say, not drop, but carefully place our irregular solid object into the graduated cylinder. And then we read the volume again. So you see how it went from 5 milliliters to start with, and then once we got the rock in there, it's 10 milliliters. So obviously the volume went up. So we can, what we do is we subtract the two. 10 minus 5 is 5. So the rock, okay, must have a volume of 5 milliliters, okay, since it displaced 5 milliliters of water. All right, so that's how water displacement works for finding the volume of different irregular solid objects. You're going to be using this in your next lab, okay, next class. We're going to be taking the density of a bunch of different rods, and you're going to use the water displacement way. It's much easier than measuring and doing all the math and stuff like that. Okay, so the last thing we just want to cover are the units for the volume using this method, and just a reminder of kind of a little conversion. Okay, so since again we're using the graduated cylinder, our units are going to be in milliliters. And then the last thing I just wanted to kind of point out and remind you of is this little conversion here between centimeters cubed and milliliters. Remember, 1 centimeter cubed equals 1 milliliter. We went over that in our measurement notes. So if you don't remember that or want a refresher on that, go back and take a look at those notes. In any case, that's the end of these notes, and we'll see you tomorrow in class. Have a good night.